Okay, so in section 1.1, we're going to talk about some definitions and key terms. And first off is, what is statistics? So it's really the science of collecting, organizing, and analyzing data. And then once we have that, we want to make sure we could make some conclusions about it or some inferences. So if we get a survey and we ask a question, about people's political affiliation, where they live, backgrounds, incomes, what does that data tell us? And so that's really the goal with statistics. And so the descriptive statistics part is actually collecting that data. So making a survey, you have all of this data. You want to make sure you organize it in a nice way so it's easy to interpret. That's what we call the descriptive statistics. Once we go through the data, we want to see what it's telling us, and we want to make some conclusions and make some inferences or kind of educated guesses. That's what we call inferential statistics. One key thing that helps us out with statistics is actually probability. And so probability is really looking at outcomes of something that's kind of likely to occur, or the chances. Those are kind of some keywords that we associate with probability. And there's really two parts to it. There's an experimental, what we call empirical statistics, and then theoretical statistics as well. And so, for example, if I were to flip a coin 100 times, if it's a fair coin, we would expect that you would get 50 heads and 50 tails. So that's kind of the theoretical part. However, if we actually flip a coin 100 times, it's probably not likely that we are going to get exactly 50 heads and 50 tails. So what we observed at empirical is the observations. We might get maybe 48 heads and 52 tails. And so that's the kind of the difference there. It's what we would expect versus what we actually observe there. Later on, what we're going to try to do is actually see if those two are close enough, right? Or if that observed probability is close enough to a desired amount where we could say, yeah, it's close to a fair coin, or it's close to being about 50-50. Some key terms here are population. And so population is everything that we're interested in. So if we're looking at college students at a certain community college, it would be all of the students there. Now, it's a lot of work to go and ask everyone a question, give everyone a survey. So we typically settle for a sample. And so it's just a subgroup of that population. And this is usually what we get due to restraints with time or finances. So we a lot of times have to settle for that sample. But there are cases when you actually could ask the entire population, and we call that a census. So for example, if we wanted to know how many units students were enrolled in at that community college, we could go to admissions and records, and they have that. They have a list of everyone's enrollment records, and so it's possible to get a complete census of that. If you're in the military and you want to know the average weight of incoming cadets, at 700 hours, everyone has to come in and report their weight. So there are cases where you could get the entire population, which we call a census. But typically, that's not available, so we're going to have to use a sample. So anything that we calculate from the sample, so if we get an average, if we get just any calculations that are done from there, if it comes from a sample, we call that a statistic. If we ask everyone and we calculate an average or some other calculations, then we call that a parameter. So if we have the parameter, that tells us exactly a characteristic of the population. And if we have that data, we really don't need any statistics. We're done. Usually that's unavailable. So what we do is we look at a sample, calculate a statistic, and we want to see if that's a good estimate for the population. So that's kind of the name of the game in this class. We're trying to get a statistic and see if it's a good estimate for that parameter. So from the sample, could we infer some things about the population? Variables, and this text will use some capital letters, X and Y, if we're talking about two variables. And so variables are those characteristics that we actually want. And then data values are the actual results that we get from that. So for example, a variable might be weight, and the data value would be 140 pounds. And that data that we get could be numerical. So for example, weight or age, those are some numerical values. And we'll later refer to that as quantitative data, so stuff that's numerical, measurable. But we could also have categorical data. So we could ask people their gender, so whether they're male, female, or non-binary, a favorite color, red, black, orange, etc. So things that are kind of put into a category, we're going to call those qualitative data. And when we talk about numerical or that quantitative data, a lot of times we're going to look at the mean or the average. And so you've probably done this if you had a few exams. If you kind of want to know your average score, you add up those exams and divide by how many there are. And this is typically used for that numerical data, that quantitative data. If we have categorical or qualitative data, we typically tend to use proportions. So if we're looking at a class of how many males and females are in there, well, I can't do any math with males and females or red or orange. So we want to find a way to quantize that data. So we typically take a proportion of that. So for example, if there are 22 males in a class out of 40, that's what we would call a proportion. And a lot of times you will see that they don't reduce it. We're typically used to reducing that into its smallest form. But if we reduce that to, let's just say we reduce this to 11 out of 20, a lot of times we lose that meaning of where did that 11 come from or where did that 20 come from. So you'll see many times that we actually just leave the proportions not in simplified forms. And so the proportion, think of that as the fraction. Okay. And a fraction really just means division. So if we divide those, we'll get a probability and we'll actually get 0.55. And so this is kind of the decimal. And if we move that over, your decimal, we're probably used to moving it over two places, all right, what we call a percent. And so a percent is always out of 100, right? That's kind of what we mean by cent here. So a century, there's 100 years, or cents, 100 cents in a dollar. So that's where we typically move that decimal over, but what we're really doing is we're multiplying by 100 in order to get a percentage. So all three of these we'll kind of use a little bit interchangeably. We should be able to kind of go back and forth with them, but they are technically different. So a proportion, a probability, and then a percent. And so here's an example. And let's see if we could kind of identify some of these definitions. So we're not going to really want to look at reciting the definition word for word. We're more interested in, can you identify that data and pick it out? So see if you could identify the population, the sample, parameter, statistic, variable, and data. So go ahead and pause it and see if you could identify that. Okay, and then here are the solutions to that exercise.